Hello friends, welcome to the part 3 of the seismic analysis. So the remaining steps include we have to define the load combinations for the load cases which we have defined in the part 2. So the seismic load cases have given in IS 1893. We can put here manually one by one, otherwise we can just add default design combos for concrete frame design, and all the combos with respect to the IS code will come, including both 1893 and IS 456. As you can see, the name decon ranging from 1 to 20 combinations came. You can double click and see the factors for the load case. After defining the load combinations, the time came to run the analysis. After running the analysis, or while running analysis, you can see it will take some time. Depends on the method of the solver of the ETABS. So there are different types of solvers. One is standard solver, second is add-on solver, and there is also one multi-threaded solver. So after running analysis, you can see the deformed shape of the whole model. You can see. Now our next step is to check the base shear of the model. So you can just press Ctrl T option to see the tables. So here I am clearing the combos because we don't want currently the results of the combinations. Here we just need the results of earthquake, static and response spectrum. So in load patterns we have to take for load pattern definitions auto seismic, and we have to go in analysis results, other output items, select the story forces. So here the load cases selected, which includes the results, and load patterns are the different, so ultimately that all are selected, and here we have to select no load combinations. After pressing OK, you can see the base shear in X and Y direction. Here I kept the unit as a ton. You can change to kilonewton as well. You can see the data, the time period used, the I and R value which we have defined previously, and the seismic weight also, and the AH value which is coefficient used. Now if you see the story forces, you will see spec X, spec Y values in Vx and Vy, which is both location bottom and top. So here you can see the base shear value and the response spectrum values are different, that both base shear we have to match, as here the code specifies or considered maximum earthquake level. So the spectrum must be converted to the specific set of units used throughout the model by applying the scale factor given as the value of gravity as acceleration in the current units of your model. So here what you have to do is the base shear by static divided by the base shear of response spectrum, you will get the factor. So that factor you have to multiply it with this scale factor in the spec X and spec Y, so that the base shear will going to match, and this is how we will scale the base shear as per the codal provision. So after that you have to again run the model when the scale factors are changed, and after running the model you can check the results again. Same, you have to go to the show tables, story forces, and go to ground or story 1. So here now you can see we have just changed the scale factor for the Y direction, and now the base shear and the spec Y value are same. Same procedure we have to do for both X and Y direction in spec load case. So here I am just putting value as a 10, but you can put the exact value which come After dividing the earthquake static base shear by response spectrum value, that exact value you have to multiply to the scale factor and change here the coming scale factor. As usual, you have to run the model after changing both scale factor and check against the base shear which is match or not. And now you can see the base shear has match, means our analysis is completed and we can proceed for next step. So after completing this, we can check the member forces and some analysis terminologies before going to directly design. So in this display option, we will find all the analysis results which we have to see, and after that we can move to finally the design. So in display option, we'll go to force and stress diagram, which contains the options like support reactions, soil pressure, frame, pier forces, shell stresses and forces. So before that, we'll explore the option deform shape. In that model case, which is mode, and mode number is 1, and we have to press apply. And you can see in the 3D view naming, it came mode shape, mode 1 is selected, and we can check the animation also. So this modal analysis gives you the information regarding the different modes of vibration, like different shape that can be taken up by the structure during vibration. This shape during different modes are called mode shape, and all mode shape have their corresponding natural frequency. So here the first mode should be translation, x and y direction, and then second mode also should be translation, and third mode should be rotational or torsional. So this is basically very important to check the structure, frequency and the mass participation ratio for all mode shapes after the analysis. So this is the part of the checking the modal response of the structure. So in ETABS we can keep the deform and undeformed shape of the model in 3D view. So after this we'll check other factors like model participation mass ratios, model participation factors. So these are all our options we can explore by opening the table, display table option, or you can just press Ctrl plus T so the tables will display. Now as you can see, we are seeing the model participation ratio load, so it is 100% for static and dynamic. Now the next part is model participating mass ratios. So here we have to check the mass participation factor in the first 3 modes mostly, and all modes also, and also we have to check the participation factor is complement to code or not. So also it is given in the clause 7.7.5.2 for number of modes to be considered. So in model participation ratio, at last mode it should be at least 90% of the total seismic mass. So means the contribution of modal mass in our model is almost 100%. So okay. So next is the story response plot. So the story maximum displacement, story drift option, we have to check for the load case, static earthquake case, EQX and EQY. So in story drift is the relative displacement between the floor above or below the story which is under consideration. So the story drift value should not be higher than 0.004 into the height of the story, which all the things which are already given in the clause 7.111.1, where they have mentioned the story drift limitations under the action of the design based shear. So the story drift value, you can see the maximum and minimum, it is written in the bracket, and here you can see the story drift from the graph. It's showing at the story 1 the story drift is there. so that should not be more than the value specified by the code. So this is about the dynamic and static analysis of the earthquake. Thank you so much. So this is the end of the part 3. We'll see you in the coming videos. Thank you.